Welcome students. Today we are going to start Newton's laws. Newton has given three laws: Newton's first law, second law and third law. These are very important laws in nature, and in Newton's first law, also known as law of inertia. In law of inertia, Newton says that whenever an object at rest will continue to remain at rest, and if the object in motion will continue in motions unless an external force will compel the object to change its position of rest or its state of continuous motion. Now we have one example under this Newton's first law of motion. The examples under this law is in which directions does the passenger fall when a bus accelerates from rest. One example under the Newton's first law. In which direction does the passenger fall when a bus accelerate from rest? In this example, suppose the bus is in a state of rest. At the beginning, the bus is at rest. There is its speed is 0. Suddenly, when the bus starts, but the bus drivers have started the bus and it accelerates. So, the passengers which are sitting inside of this are in the position of rest. When the bus suddenly starts, it means that suddenly accelerates. The bus moving forward directions, and the passengers at the beginning, the passenger at the state of rest will remain at rest. So whenever the bus is moving forward direction and the passengers falls backward direction. So this is the first examples of the Newton's law of inertia. Another important formula Newton has given, Newton's second law of motion. It says that whenever there is a force on an object, the object will change its speed. When the object changes its speed, its momentum will also changes. The change of momentum will be in the direction of the force. Suppose this is a vehicle. If a force acting on this object, on this vehicle, at the beginning its speed is u. After some time it has got the speed, new speed, that is v. So here suppose I am the mass of this object. So change of momentum, initial momentum mass into velocity, and final momentum it has mass into velocity. The change in momentum, del P means final momentum minus initial momentum. Now it becomes mv minus mu. Newton says that the change of momentum will be in the direction of the applied force. Therefore, according to Newton, the rate of change of momentum will be directly proportional to the applied force. So we have the formula F is equal to dP upon dt. This is first format of this one. Now it has another format also. After calculating this, we will get force is equal to mass into acceleration. This is second form of the Newton's second law. These are the two forms of the Newton's second law. We will discuss one example under this Newton's second law. A fielder pulls his hand gradually with the moving ball while holding a catch. You know that whenever a moving in a cricket match, when the bowler is bowling toward the batsman, when the batsman hit the ball and the ball goes to the fielders will bring its hand backward direction, because by moving the hand backward direction it increase the time of catching the ball. When it increase the time of catching the ball, the applied forces which is acting on our hands will be minimum. Okay, so there is a time whenever you increase the timing catching of the ball. When you increase the catching of the ball, the force which is acting on our hand will be very small. That's why the fielders, whenever it catch the ball, take its hand backward direction. While holding a catch. Its answer will be when a ball is coming in the hand of the fielder, it has a higher velocity. So it has some velocity v. The fielders, when catching the ball, while catching the ball, it take the ball again backward direction. It take the ball again backward direction. Suppose finally it stopped the ball in his hand, the final velocity becomes 0. So here the ball taken from this position to this position. Suppose the time starting from here and it takes t times to catch the ball or hold the ball in his hand. So here your momentum, you know that applied forces which is acting in our head. When the ball we catching the ball will apply some forces in our hand. So we want to reduce the force which is acting in our hand. So by the Newton's second law, force is equal to dp, change in momentum upon timing. This is our formula. Change in momentum divided by time. So this is directly proportional to the force acting in our hand. So whenever you increase the timing, which is in denominator, the time is denominator. When you increase the timing, the whole quantity become very small. This whole quantity is also equal to the force F. That's why whenever the fielder catch the ball, it increase the time of catching, time of holding, finally stopping the ball in his hand. So that's why he is stretching his hand by catching the ball in backward direction, due to which it increase the time. And when it is increase the time, so the force which acting in his hand will be very small. Therefore F is equal to final momentum, mass equal to 0, for moment is also, initial momentum is mass into b, time taken is this way. So this is our formula. Negative sign shown that the direction of forces on the hand is opposite to the motion. So time is in denominator, time is increasing, force will decrease. That's why the force not acting in greater amount in our hand. Another important topics, linear momentums. Linear momentum, we know that linear momentum is equal to mass into velocity. This quantity, linear momentum, this quantity we generally represent it by p. This quantity is directly proportional to mass. Greater the mass, greater will be the momentum. Also directly proportional to the velocity. Greater the velocity, greater will be the linear momentum. Therefore, the linear momentum is equal to mass into velocity. Mass into velocity. We normally represent linear momentum P by P and m into V. This is our formula. So under this we have one example. Our example is while a bus and car is moving, which will have the greater momentum? A moving bus and a moving car, which will have greater momentum. Both are moving with the same speed. So we know that a bus has larger mass. Mass of the bus has a greater mass than the car. we know that in our linear momentum linear momentum is directly depends on mass and velocity. So in this case, if the bus and car have the same speed, when the car is the same speed, but their mass is also there, the bus has the larger mass than the car. So linear momentum of the bus will be larger than that of the car. Momentum of the bus is equal to mass of the bus m1 suppose and velocity is v, and momentum of the car m2 and velocity of these two have the same. So we know that if I represent this P1 and this P2, we know mass of the bus is greater than that of the car. If you multiply both the sides by V, M1V greater than M2V. M1B, you know M1B is equal to P1 and M2B is equal to P2. Therefore, momentum of the bus is greater than that of the car.